In section 3.2, we are modeling with linear functions. So in this section, we actually introduce the idea of comparing two different models to each other. So what we want to look at in example 3 is we have two different student groups at UGA, and they're fundraising for Relay for Life. Group A's fundraiser is modeled by the following equation, right? And Group B's fundraiser is modeled by this equation, where T is measured in weeks. If the two groups start their fundraiser at the same time, how long until they've raised the same amount? So the reason we say they start at the same time is so that you know that T means the same thing in both functions, right? If we say T is 4, they've both been raising for 4 days. So if we want to know when they have the same amount of money, we can do that by finding out when these functions equal each other. So the way we can do this in our calculator, we've sort of been doing it already. We took two different functions, right, and we found their intersections. So now let's go into our y equals, clear everything out, and in y1 we're going to put the first function in, 255t plus 322, and in y2 I'm going to put 145t plus 536, right? And so I'm just going to zoom standard because I want to reset the clock, right? Because I don't think this is going to take like hundreds of weeks. So we're graphing this, and it's weird because they're both in the negative territory. That doesn't feel right. So let's go back to our y equals. These should have been lines. So 255x plus 32 and 145t plus 536. Okay, so this means that these lines are almost vertical. We can't see anything, so let's zoom fit. It's going to adjust this y scale. Yeah, now we get nice lines. And we can see their intersection. So when these lines cross, right, that is when these fundraisers are going to have the same amount in this time. So if you look at this one's sort of winning, right, till you get to this point, and then this one overtakes it. Right, so now this group has more money. So let's find the intersection. So we're going to go second calc, intersect, grab the first line, grab the second line, guess, and it says about 1.95 weeks. Actually, we should say T here. Right, which is, you know, pretty close to 2 weeks. So now we want to know, well, what is the amount that they measured, right? So if I want to know what the amount that they've measured, right, if you look right here, not only did it give us the x value, but it gave us the y value. So at this moment in time, they both have about $818.09. So the question didn't ask for that, but a lot of questions will sometimes have a part B, so it's good to know you can actually see both values at the same time, not only when they intersect, but what the value is at that intersection. All right, number 4 says, Bill just got a new sales job. He can make a base salary of $10,000 per year plus 20% of his sales revenue, or he can take a base salary of $5,000, or sorry, this should say 50,000. Missing a zero here. Plus 5% of his sales revenue. Find the linear models for his annual salary in each of the two options. So for the first one, right, his base pay is $10,000. So he gets that if he sells nothing. So we'll let f of t be his $10,000 base pay, plus he gets 20% of his sales revenue. So I'm going to call this an x. 0.2 times however many dollars he sells. The second job, we'll call that g of x, just to give it a separate name. He gets $50,000 in base pay, but he only gets 5% of his annual sales. So these are the linear models for our two options. How much will Bill earn under each plan if he sells $40,000 worth of product? So what we want to do is we want to know, well, what is f of 40,000 and what is g of 40,000? So there's kind of a neat thing you can do on the calculator with a problem like this when you have two different functions and you want to get a value and it's the same x value in both functions. So if I go back to the y equals, clear out our previous functions, I'm going to put his 10,000 plus 0.2x in the first box, 50,000 plus 0.05x in the second, and I'm definitely going to need to adjust the y scale or the x scale because I want to plug in $40,000. So what I'm going to do is I'm going to say, well, he can't have less than 0 sales, and let's go out to $50,000 in sales. And now I'm going to graph. So let it churn. You're probably not going to see anything. But now let's zoom fit. So the lines don't intersect, but that's okay because that's not what I care about. But I can see both lines. So what I want to do here is plug 40,000 in. So I'm going to go second calc, value, and we're going to put $40,000 in. So see the little cursor? It's down here on this line, right? So this is the line with the smaller slope. So this is going to be our 0.05, right? And 0.2 is bigger. So, and you also can see the intercept is much higher, right? This was the, oh, I'm sorry, this is my bad. The intercept, this is the 10,000 intercept, right? This is the 50,000 intercept. So this is function 1, right? And we can see he makes $18,000 that year if he does $40,000. So I'm just going to move this. I'm not going to touch any buttons, right? But now he has $18,000, right? Now, if I hit the up arrow, it toggles directly up to the second function and plugs 40,000 into the second function. And we can see that in G of 40,000, he makes 52,000. So when you're in this calc mode, you can toggle up and down and bounce between the two functions, and it's actually giving you the equation of the function it's plugging it into, right? So there's y1, there's y2. How much should Bill sell to make more money off the first option? And how much would he make that year? So what we want to know is, right, if we look at these two graphs, we can see, kind of like with the fundraising graph, we need to find, well, when are they the same, right? Because then one's going to pass the other because they have different slopes. And it is clearly a lot more than $40,000. So let's go back, and I'm just making an educated guess here. I'm going to go something crazy, and I'm going to say instead of $50,000, let's just blow it up to $500,000 and see what we get. So I still can't see the intersection, but it looks like we're getting closer. So now I'm going to zoom fit to adjust the Y scale. So we know it's somewhere between 0 and 500,000. So if we second calc and find the intersection, so grab the first function, grab the second function, and take a guess, we see it's $266,666.67. So that is how much in sales and typically with money we usually round to the nearest cent. His salary that year, well, we can see that too. His salary that year would be $63,333.33. Example 5 says Make Believia Inc. is making automatic homework machines. They can make 2,000 the first year, increasing by 250 every year, and 2,750 people want to buy them the first year, increasing by 100 every year. What's the first year that everyone who wants one will be able to buy one? And so there's a hint here, the number made has to be greater than the number wanted. So basically supply has to be greater than or equal to demand. So if we look out, the first year they can only make 2,000, but 2,700 people want them. So this is actually very similar to the salary problem we did in example 4. So we're going to call P of X the production, right? And we'll say, well, they can make 2,000 the first year and 250 more each additional year. So that was our slope. Then we'll make demand, we'll call that D of X, and the first year 2,750 people want one, and that's going to increase by 100 people every year. So if we set these two functions equal to each other or find their intersection, we can find the year where the supply finally catches up to the demand. So let's look at this. So we're going to clear each of these out. So we're going to put the production in first. So that's 2,000 plus 250x. Then we're going to put the demand in. So 2,750 plus 100x. And remember, our graph is still set for the last problem. So a nice baseline I like to do is let's just zoom standard, see if we can see anything. All right, so we can only see one of the lines. So I'm going to set the window at 0 because we'll start at 0, and let's say we'll go to 20 years. And I can actually go from this screen straight into zoom, and I'm going to go to zoom fit. That was 0. So it's adjusted my X scale and it's adjusting the Y scale so I can see. So we can see these two graphs intersect. And now we're going to go to second calc to find the intersection. So that's at 5. So there's our first curve. There's our second curve. Now let's take a guess. So after 5 years, supply and demand will be at 3,250. So when X equals 5 years, right, supply and demand will be 3,250. And then from that moment forward, we should see that they can always make enough to keep up with demand.